On this figure are presented location of Belgrade groundwater source with wells, boreholes, and piezometers. Like I previously said, 9 wells and 4 radial wells of Belgrade Waterworks. 54 boreholes and 1 well were made for purposes of sand mine research, and 27 piezometers for hydrogeological purposes. Based on the data obtained from boreholes, there were detected Pleistocene and Holocene deposits of marsh and alluvial origin. They consist of yellow sands and alarites, grey sand, sandy gravel, and clay. In these sediments are present 2 aquifers, upper and lower aquifer. Upper aquifers form in yellow sands with lower conductivity, and lower aquifers form in grey sands and sandy gravels with higher conductivity. Here is model layers with appropriate lithological members of the hydrodynamical model. On this map is shown the distribution of aquifer on the surface of the research area. Aquifer in yellow sands and alarite sands, and aquifer in sandy gravels and sediments. Here is a hydrogeological cross-section that shows vertical distribution of both aquifers, lower conductivity aquifer and higher conductivity aquifer. The laboratory part of the research included performing 27 grain size analyses of samples of the sediments to determine the lithological profiles in the research area. In order to determine the seepage characteristics of the aquifer, the pumping test was done on the well IB1, while the water tables were also monitored at piezometer IP1, IP2, and IP3, which are located nearby. Excuse me. Along with quantitative observations, monitoring was carried out for qualitative groundwater regime 2. 3 chemical analyses were carried out on objects IP23, IB1, and IP27. Specifically, the locations of sampling objects were chosen so that they cover 3 profiles. The first profile was the input to the direction of groundwater flow above the current mine with the object piezometer IP23. The second was located directly below the landfill of the municipal waste well IB1, which is within the current mine, while the third outward profile was covered by piezometer IP27. During the 3-month period, starting from the 12th of February to the 10th of May 2010, monitoring observations of abstracted water quantity and water tables were performed at objects of Belgrade Waterworks and sand mine in order to define the zero state of groundwater regime. And here is the figure that shows registered groundwater levels on piezometers and fluctuation of water level of the river Sava. The blue line is Sava River, and the other lines are piezometers, all 27 piezometers. For the purpose of determining the physical and chemical characteristics of rock mass and possible pollutant, it was necessary to carry out a series of laboratory experiments. Samples were collected from fine-grained yellow and alarite sands. Research methods were divided into 2 parts. The first part referred to the understirp samples, which relatively credibly reflect tearing conditions, and the other to the determination of characteristics of disturbed samples. 10 undisturbed samples were taken from the mine, and about 20 kilograms of material were taken as disturbed sample from the same location. The groundwater quality parameters from monitoring objects were analyzed, and the ones with values above maximum allowed concentrations were selected and afterwards used in laboratory experiments. And here will be given the review related to petroleum D2 because there is a possibility of its leaking during the breakdowns of machines and trucks. So, absorption properties of sediments were determined, and the time of penetration of petroleum through the individual samples was registered. Based on these values, it is possible to calculate the time of petroleum penetration to the groundwater with the aim of defining the time of intervention. The samples were treated in static and dynamic conditions. Static conditions were Applied on this tube sample, 16.3 kilogram material taken and filled with petroleum D2 to complete saturation. After that, complete decanting of the sample was done based on the difference in weight before and after the experiment. Quantity of petroleum absorbed by the sample material was calculated. Experiment consisted of 5 samples of material, and calculated values were in range from 14.5 to 18.9 weight% depending on the sample density. In other words, 1 cubic meter of material weighing 1.5 tons has the ability to absorb from 145 to 189 liters of petroleum D2. In dynamic conditions, samples were firstly subjected to long-term water infiltration, and hydraulic conductivity was determined again. After that, pure petroleum was filtered under conditions with hydraulic gradients slightly higher than natural. The obtained values of hydraulic conductivity were about 2.5 by 10 to the power minus 6 meters per second, and they roughly corresponded to the previously obtained laboratory values. Time of petroleum D2 penetration through the undisputed tube cylindrically shaped sample had an average value of 17 to 22 hours, or about 38 to 50 hours for 1 meter of overlaying aquifer. In order to show the impact of fluoride sand, exploitation of groundwater quality, a complex hydrodynamical analysis of the groundwater regime in the wider area of Jakovačka-Kumša was conducted. Hydrodynamical model of the wider area is based on three-dimensional simulation of groundwater flow. The development of the model started from the basic interpretation of input data, schematization of the porous medium, flow field, and flow conditions so that the model could be formed and calibrated. A multi-layer model was made with the possibility of an automatic change of flow field depending on flow conditions. Basic matrix dimensions that cover the studied area were 5,000 by 3,000 meters, or 15 square kilometers. Lateral discretization of the flow field in the wider research area was executed with a basic cell size of 50 by 50 meters, while the cell size in the zone of Jakovačka-Kumša was 25 by 25 meters. And on this figure is shown three-dimensional relationship between lithological objects on piezometers in green color and model mesh. For the analysis of travel time of potential pollutants from the open pit to the source well, a simulation of ideal particle movement or tracer was carried out. 2 cases were analyzed: actual groundwater exploitation with summary source capacity of 88.9 liters per second, and maximal groundwater exploitation with a capacity of 240 liters per second. Hydrodynamical model showed that it takes 35 to 39 months for the ideal particle to come from the open pit to the source well for the capacity of 88.9 liters per second. It was also concluded that all particles gravitate toward the well RB65 as a result of its highest drawdown of the water table in this object due to its location in the middle of the series and its highest capacity. For a capacity of 240 liters per second, the situation is similar, that the retention time of particles on their way from the open pit to the well is 18 to 23 months. This is a figure that shows a map of piezometric levels with travel time of ideal particle to the well with Belgrade water source in months for its capacity of 88.9 liters per second. And here is the other figure that shows a map of piezometric levels only for a capacity of 240 liters per second. So, at the end, conclusions. It was determined that it is necessary to keep the protective layer of yellow and alvarite sands 3 meter thick. Hydrodynamical analyses show that the travel time of the ideal tracer is from 18 to 39 months depending on the capacity. It is suggested to repair and reclaim the local wild municipal waste landfill located within the area of research. It is necessary to schedule the adequate program of monitoring. The zero state of groundwater quality has been determined. In the future, the monitoring of water tables at the monitoring objects at all sites should be done on a monthly basis. And in the case of possible accidents and the case of increased concentrations of some pollutant, it is necessary to expand the network of monitoring objects. Monitoring of surface water channels as the recipients should be provided to. Finally, at the end of sand exploitation, it is necessary to conduct reclamation of the open pit as well as phased reclamation. That will be it. Thank you.